Hello everyone. In this lecture, we will discuss an emerging technology known as the smart floor. Smart floors represent a significant advancement in intelligent environments and are becoming increasingly important in healthcare facilities, rehabilitation centers, sport complexes, smart homes, and industrial applications also. Traditionally, a floor is simply a structural element that supports movement. However, modern technology has transformed this passive structure into an intelligent sensing system capable of continuously monitoring human activities and collecting valuable information. A smart floor consists of multiple intelligent tiles mounted on a supporting framework. Beneath these tiles are sensor films and electronic circuits capable of detecting pressure, movement, walking patterns, and human presence. The complete system includes sensing elements, projection systems, computers, communication modules, and software that analyze collected data. When the person walks across the door, every footstep generates information. The sensors capture pressure distribution, walking speed, direction of movement, and other parameters. These measurements are then processed by a computer system to generate useful insights. One major advantage of smart floor technology is that it doesn't require the user to wear any monitoring device. Unlike wearable health trackers, the floor itself performs the sensing operations. This makes monitoring completely unobtrusive and comfortable. Healthcare professionals can use smart floors to study gait patterns, balance, and mobility. Physical therapists can evaluate recovery progress after surgery or injury. Elderly individuals can be monitored continuously for safety and fall prevention. Smart floors also support intelligent environments where the surroundings respond automatically to human movement. For example, lights can turn on when someone enters a room. Navigation information can be projected on the floor, or alarms can be activated when abnormal movement is detected. The integration of sensors, embedded systems, wireless communication, and data analytics makes smart floors one of the most innovative technologies in modern intelligence infrastructure. The true strength of a smart floor, which lies in its ability to perform a variety of measurements and measurements related to human movement and activity. These measurements provide valuable information for healthcare professionals, caregivers, sports trainers, and researchers. The first measurement is position detection. Position detection allows the system to identify where a person is standing or moving within a monitored area. So this information is useful in hospitals, nursing homes, shopping centers, airports, and security sensitive buildings. Second measurement is speed. By analyzing a sequence of footsteps, the floor can calculate walking speed. Walking speed is an important indicator of physical health. So significant changes in walking speed may indicate fatigue, injury, illness, or mobility problems. Third important measurement is acceleration. Acceleration refers to the rate of change of speed. Monitoring acceleration helps identify sudden movements, balance problems, and unusual behavior. So it is particularly useful in rehabilitation and sports applications. So another parameter is orientation. Orientation refers to the direction of movement. So the system can determine whether a person is moving forward, backward, turning, or changing direction. So this information can be used to access coordination and stability. Come to the next measurement is distance traveled. So over time, the system can calculate the total distance covered by a over the time. The system can calculate the total distance covered by an individual. So this information is valuable for activity monitoring, rehabilitation, progress assessment, and fitness evaluation. A highly important application is fall prediction. Falls are among the lead causes of injury in elderly individuals. Before a fall occurs, people often exhibit subtle changes in their walking pattern. So a smart source can detect these variations and identify individuals at risk. So if warning signs are detected, caregivers can be alerted before a serious accident occurs. Another important capability is fault detection. When a person falls, the impact generates a unique pressure pattern. The floor immediately recognizes the event, can automatically notify caregivers, emergency services, or hospital staff. These smart boards are also powerful tools for rehabilitation testing. So the patients recovering from strokes, fractures, surgeries, or neurological disorders require continuous monitoring. So smart boards provide objective data regarding recovery progress and treatment effectiveness. In physiotherapy, therapists can analyze balance, posture, step length, and walking symmetry. So this allows treatments to be customized according to patient needs. So sports science is another important application area. Athletes generate large amount of movement data during training. These smart boards can evaluate performance metrics such as speed, reaction time, jumping force, movement efficiency, and agility. Coaches can use this information to improve performance and reduce injury risk. Now we will come to the final measurement category is lifestyle monitoring. Smart stores can also monitor daily routines, activity levels, and mobility patterns. So over time, these measurements help identify changes in behavior that may indicate emerging health issues. The smart stores provide a comprehensive platform for movement analysis and intelligent monitoring. Let us now explore some practical applications of smart store technology. One of the most significant applications is in hospitals. Smart stores with integrated sensors and antennas can identify and monitor patient wristbands, staff identification badges, and medical equipment tags. So this allows real-time tracking of people and resources throughout the hospital. Imagine a large hospital with hundreds of patients and thousands of pieces of equipment. Locating a wheelchair or infusion pump or monitoring device quickly can be challenging. These smart stores help reduce search time and improve operational efficiency. In addition, hospital administrators can monitor patient movement, detect unusual activity, and receive alerts when patients enter restricted areas. Such capabilities improve patient safety and healthcare quality. Another important application is in elderly care facilities, mainly elderly individuals. Elderly individuals live independently but require ongoing monitoring. So due to some fall risks and mobility changes, they require ongoing monitoring. These smart boards provide continuous observation without affecting daily activities. The sensors can detect unusual movement patterns, prolonged inactivity, or emergency situations. So immediate alerts can then be sent to caregivers or family members. So smart boards also have significant applications in homes. Consider an elderly person suffering from memory loss. Sensors embedded in the floor can identify when the individual enters unsafe locations and can trigger voice announcements or warning messages. So this improves safety while preserving independence. Another major benefit is the potential for lowering health costs. or healthcare costs. Preventing injuries is often far less expensive than treating them. Early detection of mobility problems enables healthcare providers to intervene before serious complications arise. This reduces hospitalization costs and improves patient outcomes. One fascinating advancement is the generation of electricity from footsteps. Certain smart floor systems use energy harvesting technologies that convert mechanical pressure into electrical energy. Every step taken on the floor contributes a small amount of power generation. Although a single step generates a small amount of energy, thousands of people walking across busy public locations can produce significant cumulative power. Applications include these public locations include railway stations, airports, shopping malls, stadiums, educational institutions, smart city infrastructure. So generator power can operate sensors, lighting systems, displays and communication devices. Therefore, smart floors contribute not only to intelligent monitoring but also to sustainable energy solutions. The images shown on this slide represent practical implementation of smart floor technology in healthcare, rehabilitation and intelligent monitoring environments. These examples demonstrate how sensor-based flooring systems collect in movement information and convert it into useful data for analysis and decision making. In rehabilitation centers, therapists use smart floors to track patient recovery objectively. Instead of relying solely on visual observation, quantitative measurements provide precise information regarding improvement and treatment effectiveness. In hospitals, smart floors improve patient safety by identifying mobility problems and detecting faults. Healthcare personnel receive timely alerts and can provide immediate assistance when required. In smart homes, intelligent flooring enhances independent living for elderly residents while ensuring continuous monitoring and protection. So these systems contribute significantly to improving quality of life. So as technology continues to advance, smart floors are expected to become increasingly common in future buildings, smart cities, transportation hubs, healthcare facilities, and educational institutions. So let us briefly summarize what we have learned in smart floor. A smart floor consists of intelligent tiles, sensor films, and processing units, and software systems. So it measures parameters such as position, speed, acceleration, orientation, distance traveled, and movement patterns. So the technology supports fall protection, fall detection, rehabilitation assessment, physiotherapy evaluation, SMONS monitoring, and lifestyle analysis. Applications extend across hospitals, nursing homes, smart residences, sports centers, and public infrastructure. Smart floors also contribute to energy harvesting and healthcare cost reduction. This concludes our discussion on smart floor technology. Now let us see a conclusion on the topics that we have covered under home appliances and home enablement systems. Dear viewers, we have now reached to the conclusion of this lecture on home appliances and home enablement systems. In today's world, the technology has become an integral part of our daily life. Home appliances are no longer simple mechanical devices. They have evolved into intelligent systems that use electronics, sensors, microcontrollers, communication networks, and automation techniques to improve convenience, maybe convenience, safety, efficiency, and quality of life. So we began this lecture by studying RFID technology. That is the first topic. So a wireless identification system that enables automatic recognition and tracking of objects. We learned about RFID tags, readers, classifications based on frequency, and the advantages of RFID systems. We also saw how RFID can be used in smart homes for applications such as automated lighting control and home enablement solutions. Next, we explored the washing machine, one of the most widely used household applications. It is one of the most familiar household appliances also. We discussed its operating principles based on centrifugal and centripetal forces. Different types of washing machines also we have discussed, and electronic control systems, input and output devices of washing machines, and important components of washing machines such as sensors, motors, pumps, and agitators. We observed how automation has made washing machines more efficient and user-friendly. We then moved to modern kitchen appliances, beginning with the microwave oven. We learned that microwave ovens convert electromagnetic energy into thermal energy through direct heating by exciting water molecules inside food. Microwave ovens provide faster cooking while preserving a greater percentage of nutrients compared to traditional cooking methods. So along with microwave ovens, we examined the dishwasher, an appliance designed to automate dish cleaning. We studied its construction, major components, and working mechanism involving heated water, spray arms, pumps, sensors, and drying systems. Dishwasher demonstrates how automation can reduce human effort while maintaining hygiene and efficiency. This lecture also introduced the induction stove, which operates using electromagnetic induction. Unlike conventional cooking methods, induction stoves generate heat directly in the cookware through eddy currents. This results in faster heating, improved safety, and higher energy efficiency. We also discussed pan detection mechanisms that prevent unnecessary power consumption and enhance user safety. Another important topic was uninterruptible power supply or UPS. We learned how UPS systems provide backup power during electrical failures and protect sensitive electronic equipment from interruptions. We studied the major components of UPS systems including batteries, rectifiers, inverters, and static switches. We also compared offline and online UPS systems and explored their applications in hospitals, data centers, industries, and communication networks. Moving further, we explored the concept of smart refrigerator. Smart refrigerators represents the convergence of refrigeration technology and internet connectivity. Equipped with sensors, cameras, digital displays, and wireless communication, these appliances can monitor stored food items and create shopping lists and send notifications, interact with other smart devices. Such intelligent features improve food management, reduce waste, and enhance convenience for users. We then focused on smart home security systems, including smart alarms and smart locks. Smart alarms use indoor and outdoor sensors to detect motion, vibration, intrusion, and other unauthorized access. Smart locks eliminate the need for traditional keys by enabling password-based, smartphone-based, or wireless access control. These technologies enhance security, provide remote monitoring capabilities, and offer greater flexibility for homeware owners. Finally, we discussed smart door technology, an innovative application of embedded sensing systems. Smart doors can monitor position, movement, speed, acceleration, and activity patterns. These are widely used in hospitals, rehabilitation centers, nursing homes, sport facilities, and smart buildings. Smart doors play a crucial role in healthcare monitoring, fall detection, patient assistance, and even energy generation through footstep based on energy harvesting systems. So I hope you understood this lecture on home appliances and home enablement systems. So kindly watch this summary video with the previous video PPT. So thank you for watching this lecture.